In the previous video of this session, we have learned about ReentrantLock class. In this video, we are going to learn about ReentrantReadWriteLock class in details. The ReentrantReadWriteLock class is an implementation class of the interface ReadWriteLock. Namaste everyone, I am Gyan and you are watching the session 20 of Java and Web, Multithreading in Java. Let's look at this scenario. This is the seat booking app of a bus and this is the available seats in a bus. Suppose that a user just wants to see the number of seats available in the bus. Such users are called reader users. But when a user wants to book a seat available in the bus, then such users are called writer users. When a reader user using the app to just see the number of available seats, in that situation, multiple other reader users may be allowed to use the app because they just have to see the current available number of seats. When a writer user is booking the seat, then other reader users should not be allowed to see the number of available seats. And at the same time, multiple writer users also should not be allowed to update the information of the seat. Therefore, the multiple reader users can access an object simultaneously because they do not have to update. They just have to see the information. But when a writer user is using the app, other users, either reader or writer, should not be allowed to access the app. Although the app creators comes with very good solution for this problem, but this is the situation they need to solve while creating such a booking app. See other scenario, if you have a public notice board, then multiple reader users can read that notice board. But if one writer user is writing something on the notice board, then other reader users or writer users are not allowed to access that notice board because status of that public notice board is not stable when a writer is writing something on the notice board. There is the same case in Java. Multiple threads want to access an object. Few threads are readers and few threads are writers. Multiple reader threads are allowed to access the object simultaneously. But if one writer thread is accessing an object, then other threads, either reader or writer, are not allowed to access that object. We can achieve this functionality by using ReadWriteLock. The ReadWriteLock is an interface present in the package java.lang.concurrent.locks. The ReadWriteLock interface has two methods, ReadLock and WriteLock. Both methods return a reference of type lock. We already have studied about the lock interface in the previous video of this session. The ReadWriteLock interface is implemented by a class ReentrantReadWriteLock, and the class is also present in the same package java.util.concurrent.locks. This is the structure of ReentrantReadWriteLock class. If you go to the source code of ReentrantReadWriteLock.java, then you will find that the ReentrantReadWriteLock class implements the interface ReadWriteLock. The two constructors of the class ReentrantReadWriteLock are, first one is the default constructor and the second one which accepts a boolean as its argument. If you are creating an object of this class by using the constructor with boolean as its argument, in that case, if you pass true as the argument, then it will create a ReentrantReadWriteLock object with fairness. Means longest waiting thread will get the first chance on the CPU. And if you pass here false, then it will not consider the fairness. If you are using the default constructor, then also the fairness will not be considered. We already have seen the programs with fairness when we studied about the ReentrantLock class. After that, the two implemented methods of the interface ReadWriteLock, the method ReadLock and the method WriteLock. The method ReadLock is a public method which returns a reference of type inner class ReadLock, and the method WriteLock returns a reference of type inner class WriteLock. As you have seen, the class ReentrantReadWriteLock has two inner classes, ReadLock and WriteLock. Both the inner classes implements lock, the lock interface. These classes have protected constructors and they implement all the methods of the lock interface. The reference to these two classes are returned by the ReadLock and WriteLock method. And these two methods were present in the interface ReadWriteLock, which got implemented in the class ReentrantReadWriteLock class. Hopefully you are getting my points. Then after, we have multiple other methods present in the ReentrantReadWriteLock class. All these methods are same as the methods present in the ReentrantLock class with some read-write specification, of course. Because now we have two types of locks, ReadLock and WriteLock. And when you have methods which are specific to the ReentrantReadWriteLock class, then those methods should deal with both read-locks and write-locks. But most of these methods was already present in ReentrantLock class, as we already have seen. So I'm not going to create separate videos for all the methods present in the ReentrantReadWriteLock class. That I did with ReentrantLock class. Here I'm going to discuss all the methods of the ReentrantReadWriteLock class in this video itself. The ReentrantReadWriteLock class implements both the methods of ReadWriteLock interface. These two methods. Both the methods returns reference of type lock interface. The ReentrantReadWriteLock class has two implementation classes, that is inner classes of the interface lock, ReadLock and WriteLock. These two are classes. The method ReadLock returns reference of this inner class, means reference of the inner class ReadLock, and the method WriteLock returns reference of this inner class, means the reference of the inner class WriteLock. All the methods of the interface lock are implemented by classes ReadLock and WriteLock. Therefore, as we already have seen, we have two kinds of lock, ReadLock and WriteLock. The reader thread can access the ReentrantReadWriteLock object simultaneously, but only one writer thread can get a chance to lock ReentrantReadWriteLock object. A writer thread cannot share an object with another writer thread or with another reader threads. So let's use the ReadWriteLock. But in this example, let's use the ReadLock part of the ReentrantReadWriteLock. Here we have the Java file CreateThread.java. In the CreateThread.java, we have the class CreateThread. We have imported all the classes from the package java.util.concurrent.locks. In the CreateThread.java, we have the method main, where we are creating a new object of type ReentrantReadWriteLock. Then after, we are creating 5 new threads, and we are passing the same reference of the ReentrantReadWriteLock class to all those threads. After that, the thread started its execution, and here we are calling lock.readlock.lock. Now see what this statement is doing. This is the readlock method. When you call the readlock method by using the reference variable of type ReentrantReadWriteLock, then it returns a reference of type readlock. And the class readlock implements all the methods of the interface lock. So it also have implemented the method lock. Therefore, this part of this statement, lock.readlock, returns a reference of type readlock object. And by using the reference of type readlock object, we are calling the method lock. Therefore, here the thread is getting a lock on the readlock object. Then after, we are printing the thread name got the lock. Then after, the thread goes for a sleep of 5000 milliseconds, means 5 seconds. After that, the thread calls the unlock method on the same readlock object. Then we print the name of the thread, releases the readlock. Let's try this code practically. Open CreateThread.java, and this is the same code as we have seen. Open MyThread.java, and this is the same code as we have seen. Just make the sleep time little less. Make the sleep time as 3000 milliseconds. Now compile these two codes. Java C, MyThread.java, CreateThread.java, compiles fine. Now run it. Java create thread. It runs fine. And as you can see, all the threads got the lock simultaneously, because more than one threads get the read lock simultaneously. Let's change something in the code. Let's open MyThread.java, and right here the reference variable lock, the reference variable of type ReentrantLock, right here lock, that will result in the toString method of the ReentrantReadWriteLock. And the toString method of the ReentrantReadWriteLock class returns the number of read locks and the number of write locks on the current object. So let's execute this code once again and see the output. Compiles fine, clear the screen, run it, Java, create thread. It runs fine. And as you can see, the number of write locks are 0, while the number of ReadLocks are 5 in all these 5 cases. So all the 5 threads got the ReadLock simultaneously. This is the same code as we have seen, but only difference is that here the threads are trying to get the RightLock instead of ReadLock. So let's execute this code and see what will happen if the threads are trying to get the RightLock instead of the ReadLock. Open MyThread.java once again and just make it RightLock instead of ReadLock. RightLock. Just make it RightLock. Try to compile these two codes, Java C, MyThread.java, CreateThread.java, compiles fine. Now run it, Java create thread. It runs fine. And at this time you can see only one thread can get the RightLock at a time. You can never find more than one RightLocks are taken by any thread. And if RightLocks is equal to 1, then the ReadLock will always be 0. Further, the RightLock cannot be more than 1. Again, this program is same as we have seen earlier. The code of this program is also given in the video description. Only difference is that we have a constructor of the class MyThread which is accepting 3 arguments: the reference of the Reentrant ReadWriteLock and a string reference. Then we are passing the string R to the constructor of the class MyThread if the value of I is even, and we are passing the string W to the constructor of the MyThread if the value of I is odd. So what we are trying to do is, we are trying to make the even threads as reader threads, and we are trying to make the odd threads as writer threads. So 3 threads can get a chance on the lock simultaneously. But when a writer thread is present on the lock, then other threads will not be allowed to get that lock, either reader or writer. Therefore, if the read-write string is W, then the thread will get a write lock. And if the read-write string is R, then the thread will get a read lock. So let's see the execution of the code. Open CreateThread.java, and this is the same code as we have seen. Now open MyThread.java, and this is the same code as we have seen. Just here, instead of printing the value of RW, I want to print the value of lock, the value of the reference variable lock, because I want to see that how many threads can get read lock and how many threads can get write lock simultaneously. Because here both types of threads, reader thread and writer thread, are working together. Now compile this code. Java C, CreateThread.java, MyThread.java. Compiles fine. Now run it. Java create thread. And this is the output. T0 and T2 got 2 reader locks simultaneously. Here you can see write locks is equal to 0 and read locks is equal to 2. But whenever a thread gets a write lock, no one has a chance to get the read lock or write lock. Okay, write locks cannot be more than 1, and whenever the write lock is 1, the read locks will be 0, will be always 0. Finally, T4 gets a chance to get a read lock. Here we have the same code as we already have seen in the previous slides. Here only difference is that we are getting a reference variable of type Reentrant ReadWriteLock object, whose reference will be stored into the reference variable lock. Then by using the reference variable lock, we are calling the WriteLock method, and by using the reference variable lock, we are calling the ReadLock method. This statement returns a reference of type WriteLock, which will be stored into the reference variable of type lock. And this statement will return a reference of type ReadLock that will be stored into the reference variable of type lock. Finally, we are passing the reference variable WriteLock into the constructor of the class MyThread. So we have passed the reference variable of type WriteLock to the constructor of the class MyThread. And by using the reference variable WriteLock, we are calling the lock and unlock method. So instead of passing the reference variable of type ReentrantReadWriteLock, we are just passing the reference variable of type WriteLock, and that is perfectly working. Let's execute this code practically. Open CreateThread.java, and this is the same code as we have seen. Open MyThread.java, and this is the same code as we have seen. Just make the sleep time to 3000 instead of 5000. Right here 3000. And print the reference variable RightLock, the value of the reference variable RightLock, that will return the number of RightLocks currently present on the object RightLock. Compile this code, Java C, CreateThread.java, MyThread.java. Compiles fine. Now run it, Java, create thread. It runs fine, and you can see the thread T2 got the RightLock, and this is the class name java.util.concurrent.locks.reentrantReadWriteLock $RightLock. This is the hash code of the class and locked by the thread T0. Only the thread T0 has locked this RightLock, and this one is locked by T1. So you can see a RightLock can be locked by just one thread. We are getting this output because we have just printed the reference variable of type RightLock. Initially, we were printing the reference variable of type ReentrantReadWriteLock. The toString method of that reference variable had the information about both read and write locks, but here since we are printing the reference variable of type WriteLock, therefore we are getting the information about just WriteLock. Let's change something in the code. Let's open MyThread.java, and I made this code to work on the ReadLock instead of WriteLock. Further open CreateThread.java, and I made this code to work on the ReadLock instead of WriteLock. So I changed this code. Now compile these two codes. Compiles fine. Now run it. Java create thread. It runs fine. And as you can see, all the threads got a read lock simultaneously. Total number of read locks are 5 for all the threads. As we already have seen, the structure of the ReentrantReadWriteLock class, which contains two inner classes, ReadLock and WriteLock. Let's see what the methods are present in the ReadLock and WriteLock classes. Of course, the constructor of these classes are protected, but we need to know about all the public methods of the ReadLock and WriteLock inner classes because we can directly use them. These are the methods present in the ReadLock inner class. When you call lock.readLock, then you can use these methods on the reference returned by the lock.readLock call. The methods are lock, lock interruptably, tryLock, tryLock with arguments, unlock, new condition, and toString. So if you remember, we already have learned all these methods with ReentrantLock class. Therefore, in this video, I am not going to discuss these methods. You can apply these methods on the reference variable of type ReadLock and check how they work. These are the methods present in the WriteLock class. The method lock, the method lock interruptably, the method tryLock, tryLock with arguments, unlock, new condition, toString. The toString method prints the name of the thread which retain the WriteLock. It does not print the number of ReadWriteLocks. This statement is wrong here. Then after, we have another method is held by current thread. We already have seen this method while learning about ReentrantLock class. And we have another method get hold count. We already have seen all these methods while learning the ReentrantLock class. They are applicable on the WriteLock class in the similar manner. And these are few methods which are specific to the ReentrantReadWriteLock class. These methods do not belong to ReadLock class. These methods do not belong to WriteLock class. They just belong to ReentrantReadWriteLock class. So by using the reference variable lock of type ReentrantReadWriteLock class, you can call these methods. The first method is fair. If you have implemented the ReentrantReadWriteLock class, have you considered the fairness while implementing the ReentrantReadWriteLock object or not? You can consider the fairness while implementing the ReentrantReadWriteLock class. When you pass here, just true. If you pass true as the argument, then you are considering the fairness. Means longest waiting thread will get the first chance on the lock. Try to compile it. Compiles fine, and you can execute. The output will be same, but at this time you are considering the fairness. You are considering giving the chance to the longest waiting thread earlier than other threads. Other method is get ReadLock count, means how many threads got the ReadLock. Other method is is write locked, means is there any thread which got the write lock? Another one is write locked by current thread. The another one is get write hold count. As you remember, you can call the lock method more than one times. We did it with ReentrantWriteLock Class. We can call l.lock more than one times. In the similar way, you can call l.WriteLock.lock more than one times. Remember that more than two threads are not allowed to get the write lock simultaneously. But one thread can call the WriteLock method more than one times. Similarly, we have get read hold count method. Means how many times a given thread called the lock method on a readlock object. After that, has queued threads with thread as its arguments. After that, get queue length, has waiters for this condition. Is there a thread which released the lock because of this condition? If yes, then this method will return true. From the earlier video of this session, we know that a thread can release the lock because of the given condition. We already have seen such program in the earlier video of this session. Other one is, what is the length of the waiting queue for the threads which are waiting for a given condition? And last one is toString, which prints the number of read and write locks. This one we already have seen when we have printed the reference variable of type ReentrantReadWriteLock class. So that's all about ReentrantReadWriteLock class. Hopefully you got all my points. That's all for this video, guys. Don't forget to like and share this video, subscribe my channel on YouTube, like my page on Facebook, and leave your valuable comments in the comment section below. Thanks for watching. See you in the next video.